Today I'm working with a question I took straight from a YouTube video. You can see it on your screen right now. Before anything else, I removed all the objective answer options so that I could present the bare question to the NHE AI tutor. The clean question is now ready on my desktop, and it's on linear expansivity, a topic that falls under mathematics, though it also appears in physics. Now let's open the AI Tutor interface. I'll launch the new Higher Education AI Tutor and make a few quick settings before uploading the question. First, I set the level to SHS 3, then I choose the subject and pick mathematics, since that's the primary subject for this topic. With that done, here's the question again. I upload it directly from my desktop into the app. Once the upload is complete, all that's left is to click on Get Answer. The orange Get Answer bar will turn green to show that the AI tutor is generating the response. I'll wait a moment while it processes, and when the bar changes back to orange, that's my signal that the full answer is ready. Let's walk through it together. First, you'll see a clear overview of the solution. Then a button appears, Show Full Answer. Go ahead and click it, and just like that, the AI tutor delivers the complete, detailed breakdown. As you scroll down, you'll find a rich step-by-step explanation that leaves no part of the question unexplained. But we're not done yet. Here's where it gets even better. Look at the teacher audio option. You can choose between a male or female voice. I'll select the female teacher, then tap the orange bar that says Generate Optional Audio. While it processes, the bar turns green and reads Generating Teacher Audio. What makes this special? The audio doesn't just read the answer aloud, it teaches. It expands on the topic with the depth and clarity of a real instructor, giving you context and insight beyond the written text.
Let's begin by carefully reading the question. Example 1. A wire of length 5 meters is heated from 10 degrees Celsius to 60 degrees Celsius. If it undergoes a change of length of 20 millimeters, the linear expansivity of the wire is. Objectives. By the end of this lesson, you should be able to define linear expansivity, use the formula for linear expansivity to solve practical problems, apply unit conversions correctly in calculations, and solve exam-style questions involving thermal expansion. So our main goal is to understand what linear expansivity is and how to calculate it using the right formula and units. Key terms. Linear expansivity, often written as alpha, is the fractional increase in length per unit original length per degree Celsius or Kelvin rise in temperature. Thermal expansion is the increase in size, whether length, area, or volume of a material when its temperature increases. Delta L, written as delta L, is the change in length, which is the final length minus the original length. L naught, or L sub 0, is the original length. Delta theta, written as delta theta, is the change in temperature. Take note of these terms as they will appear in our calculations. Prior knowledge. You should already know how to convert between millimeters and meters, how to subtract temperatures to find a temperature change, and some basic algebraic manipulation. Remember, always use SI units in your calculations, especially for length and temperature. Core explanation definition. Linear expansivity alpha is given by the formula alpha equals delta L divided by L naught times delta theta, or in words, linear expansivity equals the change in length divided by the product of the original length and the change in temperature. Unit. The SI unit for linear expansivity is per degree Celsius, written as degrees Celsius to the power of -1 or per Kelvin. This means your final answer should always have the unit per degree Celsius or per Kelvin. Worked example, solving the given problem. Given original length, L naught is 5 meters, initial temperature is 10 degrees Celsius, final temperature is 60 degrees Celsius. Change in length delta L is 20 millimeters. Step 1. Convert all quantities to SI units. Delta L is 20 millimeters. To convert to meters, divide by 1,000. So 20 divided by 1,000 equals 0.02 meters. Delta theta, or the change in temperature, is 60 minus 10, which is 50 degrees Celsius. Step 2. Substitute into the formula alpha equals delta L divided by L naught times delta theta. So alpha equals 0.02 meters divided by 5 meters times 50 degrees Celsius. That is 0.02 divided by 250. This gives 0.00008. Step 3. Write the answer with the correct unit. Alpha equals 0.00008 per degree Celsius. Or, in scientific notation, alpha equals 8.0 times 10 to the power of minus 5 per degree Celsius. Final answer, the linear expansivity of the wire is 8.0 times 10 to the power of minus 5 per degree Celsius. Take note, always check your units and make sure your answer is in the correct form for exams. Ghana context example. Suppose a metal rod is used in constructing a bridge in Accra. If the rod is 10 meters long and the temperature changes from 25 degrees Celsius in the morning to 45 degrees Celsius in the afternoon, and the rod expands by 16 millimeters, you can use the same method to find the linear expansivity. This is important for engineers to prevent structural damage due to expansion. So, in real life, engineers use this calculation to make sure structures like bridges and railway tracks are safe. Common misconceptions. Some common mistakes include forgetting to convert millimeters to meters. Always use SI units in calculations. Also, mixing up delta L and L naught. Remember, delta L is the change, L naught is the original length. And finally, using the wrong temperature difference. Always subtract the initial temperature from the final temperature. Watch out for these errors, especially under exam pressure. Practice question with marking guide. Question: a steel bar of length 3 meters expands by 6 millimeters when heated from 20 degrees Celsius to 70 degrees Celsius. Calculate the linear expansivity of the steel bar. Marking guide 1. Convert 6 millimeters to meters. 6 millimeters equals 0.006 meters. That is 1 mark. 2. Find delta theta. 70 minus 20 equals 50 degrees Celsius. That is 1 mark. 3. Substitute into the formula. Alpha equals 0.006 divided by 3 times 50, which is 0.006 divided by 150, giving 0.0004. That is 1 mark. 4. Final answer. Alpha equals 4.0 times 10 to the power of minus 5 per degree Celsius. That is 1 mark. Try to follow these steps in your own calculations. Exit ticket question. If a 2-meter aluminium rod expands by 1 millimeter when heated by 25 degrees Celsius, what is its linear expansivity? Pause and try this question on your own before checking the answer. Homework 1. A copper wire of length 8 meters expands by 24 millimeters when heated from 15 degrees Celsius to 65 degrees Celsius. Find the linear expansivity. 2. Why is it important for engineers to consider linear expansivity when designing railway tracks in Ghana? References. You can find more on this topic in your mathematics curriculum and standard physics textbooks on thermal expansion. Exam tip: always convert all measurements to SI units before substituting into the formula, and write your final answer in scientific notation if possible. Quick check: if a rod of length 4 meters expands by 8 millimeters when heated by 40 degrees Celsius, what is its linear expansivity?
And here's an added bonus. After your first generation, you can ask up to 5 follow-up questions to dive even deeper. NHE AI Tutor app is like having a personal tutor who speaks, explains, and responds, all at your fingertips. And there you have it, clear proof of how thoroughly and effectively the new higher education AI tutor breaks down even complex questions. This isn't just a one-off example, it's a glimpse into how this tool handles any subject you throw at it. Whether you're studying literature, science, or mathematics, this AI tutor is designed to help you reach your academic goals with ease. What's more, the solution was not only accurate, but also remarkably simple to follow. That's because you're not just using an app, you have a virtual teacher right in your hands. And the best part? It works seamlessly on your phone, meaning you carry a full-time tutor in your pocket, ready whenever you need it. So if you're a student, whether in junior high school, senior high school, or beyond here in Ghana, don't overlook this powerful tool. It could be the difference between struggling through your studies and passing your exams smoothly, confidently, and without unnecessary stress. Get the app, stay ahead, and make your learning journey a whole lot easier. That was NHE AI Tutor app in action. I will come to you with another video. Thanks for watching.